Hi everyone. Hello. Hope you all are doing great. Happy Janmashtami to everyone. I am Preeti, your host for today, and I'm excited to welcome you to this engaging and informative session on Docker containers. Now, I am delighted to introduce our speaker, Mr. Ramanuj Das. Ramanuj is a seasoned IT professional with a rich decade-long journey as a software developer, DevOps engineer, Agile coach, and corporate trainer. Throughout his dynamic career, he has collaborated with over 50 clients on a global scale, leveraging his expertise to deliver success across diverse IT landscape. With his vast knowledge and hands-on experience, Ramanuj has been instrumental in guiding organizations to adopt modern DevOps practice, streamlining CI/CD pipeline, and harness the power of Docker containers for scalable, efficient, and resilient system. We are truly excited to have him with us today to lead this insightful session. Let's give a warm welcome to Mr. Ramanuj Das. Over to you, sir.
Hey Preeti, thank you so much. And hello everyone, this is Ramanuj, and already Preeti has told about me, right? So I am a software developer as well as a corporate trainer. I've been working in this industry for around last 1 decade, that is almost 10 years. And I have been, I've worked as a software engineer, I have worked as a DevOps engineer, and I currently am working as a corporate trainer. I've been delivering training for some of the great clients around this globe, right? So not only in India, so some of the other places like US, and the other countries as well, right? So the major things that I do is mostly nowadays is on DevOps, and apart from that, I had been a developer, and mostly I was developing full stack application, mostly in Java and microservices and so on. So that's about me, and we would start, right? So I would just share my screen. And also let me tell you, right, so at the if you during this session, right, as you know, right, it's a very short session, right? So 2 hours of session. And if you have any questions or anything at the end, I would give you time to ask your question, right? Okay. So let me share the screen. Just give me 1 minute. Okay, so hopefully the screen is visible. As you know, the name of our today's content or today's topic is Docker and GitHub Actions. Okay, so I would do one thing. I think I don't need this camera right now. Okay. So yeah, so it's Docker and GitHub Action, and let's try to understand what is Docker and what is GitHub Actions. Okay, so well, let me tell you first thing. I'm not a PPT person. This is the only screen slide that you are seeing. Mostly, I use whiteboard to explain. So well, let's get started from here. Okay, so in order to understand what Docker is, first and the most important thing, like you should know or you should have some idea of application development or application deployment. Okay, then only we'll understand it more precisely. And before I actually explain what Docker is, let me show you some interesting thing. Okay. So I'm not sure, how many of you actually use any cloud platform like AWS, Google, GCP or anything, but let me show you a very simple and easy thing. Let's suppose I'm going to my Google Cloud. Okay. So this is my Google Cloud, you know, this is my Google Cloud dashboard. And you think, if at all I want to deploy an application, right? If at all I want to deploy an application, what and all things, right? Let's quickly do an application deployment here. Okay, I want to deploy an application on GCP. GCP. Okay, I want to deploy an application on GCP. So, what are the steps that I need to do in order to deploy an application? If at all I want to run any application on any cloud platform, first of all, that cloud platform or wherever I'm running that application, so maybe on a virtual machine, maybe on any service, so that must have, if I am, let's suppose I'm running a Python application, I'm deploying a Python application. Okay. Or I'm deploying a Java application. So in both the cases, if I deploy a Python application, Python must be installed there. If I'm deploying a Java application, JDK must be installed there. But let me show you a very interesting thing. So I have an application and I want to deploy it on GCP. Okay, so quickly, so there is a service in GCP which is known as Cloud Run. Let's explore that Cloud Run. Okay, so let's quickly click on this. It will take you to the Cloud Run. That's a service. That's a service from GCP. And here, what I'm going to do, I'm going to write a name of an application. Let's suppose I've given uh, the name of an application, or there is a location where the application is, right? So I have just given that information, and I would say host it on maybe, okay, let's use Asia, maybe Mumbai, right? So let's host it on Mumbai. Okay. Or else we'll use US Central one. That is actually better. Let's US Central one. Okay. So I'm hosting it here. Apart from that, I am not giving any other stuff, right? So let it be everything as it is. And I'm going to click on create. Okay. So you've seen, just I have given the location where the application is, and all that I clicked on a create button. Okay. There was a button, and you see this is live, right? The application, that's a very simple and easy application. It's not something very big. I mean, a pretty simple application, whatever it might be, but that's live right now. And in fact, you can also check, what if I share, okay, what if I share the location or the URL to you as well? Just a minute. Okay, so you can also cross check that the application is live and you are able to access this application. So I am showing this. Okay, try to understand the way I have deployed this application. I never told that this is a Java application or a Python application or a JavaScript application. I didn't say all those things. I didn't say all those things. All that I do is just given a location where the application is present, and it got deployed within seconds, within a few seconds. You have seen, right? So how much time it took to deploy that application. It's running right now. You can see that the application is running. Okay. The application is running. So you see that kind of thing, how exactly it is possible. Why? I'm not saying that what kind of application it is. I didn't do any kind of installation or anything. How exactly it's possible? Well, that's possible because of Docker. That's possible because of Docker. Now let's understand what is Docker and what exactly it does, what problem it solves. Whenever we are building any application, let's suppose any kind of application, I might have built you know, a Java application. Okay. So think of it is a Java application. Think of it's a Java application. Okay. Now, if it's a Java application, how do we run a Java application? Well, in order to run a Java application, we would we need the final, like let's suppose there is a Java application. So we need to build that application, and ultimately we get a jar file. Okay. There's a file called Java archive, a jar file. So when we run that jar file, there are certain command, right? So there is a command called Java minus jar, and then write the name of the jar and so on, right? So that's how we run a Java application. But we cannot run this jar application anywhere or any machine directly. In order to run that Java application, we must have the Java installed on our machine. Okay, so we must have the Java installed on our machine. Then only I would be able to run that Java application. Same goes with any other application. Let's suppose I have an application, Python application, right? So I have something app.py. That's a Python application. Well, in order to run that Python application, again, I build that Python application, and if I have to run that Python application, I need a machine which have Python runtime installed. So I must have a machine which have Python runtime installed. Again, there are version compatibility as well. Right? Let's suppose I build an application with the Java 21, and on that system Java 17 is installed. Of course, it won't be able to run that application. Same goes with Python, right? So I have developed an application with one version and trying to run that with a different version. That would create a lot of issues, and that ultimately would lead to an issue which is known as it works on my machine. Okay. So imagine you are a developer, you have developed an application and which is absolutely running fine on your machine. But the moment you have given it to the operations, to the deployment team, they are not able to run it on their machines or on the cloud machine. And that's a very common and very usual scenario in IT industry. And now it got resolved because of Docker. So what exactly Docker does? What is Docker and what exactly it does? Docker is a containerization platform. Okay. Docker is a containerization platform. If you look at the logo of Docker, you would find that it looks like a fish, but it's not a fish, it's a ship. Okay. So the symbol of Docker is actually a ship. Okay. Okay, you are not able to access the shared URL. Okay. Um, okay. Not sure. Maybe your network is having some of the other issues, but this is public URL, right? So whatever I've shared, that's a public URL, and that's okay even if you are not able to share. This is like I'm running an application, that simple application, and that's showed you that we can run using Docker. That's a very basic thing. I mean, it's okay if you if you're able to access, that's great. If not, that's okay. Anyway, so look at this. If you look at Docker, you would find that that's actually a ship, and what it is shipping is a container, right? So from one machine you can think of, this is your dev machine or this is your prod machine, prod, and that is production, and this is your dev, right? So you are developing your machine software on your machine and you want to ship it to the production or you want to ship it to the cloud. Maybe let's not write prod directly. Let's suppose you want to ship it to the AWS. You want to deploy your application on AWS, and Docker is going to help you out. Docker is going to help you out. How? So Docker has a concept called container, right? So you see what we are shipping is container. Look at this container. Now, if you think of the shipping industry, how there are multiple things that we ship, right? So lots of things are coming from US, India to US, going from in US to India, and so on, right? So we ship a lot of things. So the way we ship or the way we load, think of it, right? The way we load a bag of rice on a ship is definitely not the way we load a car or a bike on a ship, right? So we need different mechanism to load different things. But that is very challenging, and that's how they solved it, by using containers. So it doesn't matter what is there inside the container, whether it is a car, whether it is a bike, or it's some bag of rice or whatever it might be. The way we ship any container would be same, right? So there are certain machines or hooks in that shipping industry, and they will use it and they would use that to ship that. Same way, same concept we are applying on our machines as well, or our IT industry as well. How? So what we do, the entire application, imagine we have a Java application or a Python application. So we have a uh, app, right? So in case of Java, it is app.jar. And in order to run that application, what is needed? The JDK or the JRE runtime. So let's think of JDK. Okay, so we combine both of them together. We combine all the things which are required in order to run that application together, and we ship that. Okay, rather than shipping only that app.jar file, which definitely needs some dependency, like which needs JDK and other dependencies. So I'm packaging everything with whatever is needed in order to run my application all together, that you don't need to install, you don't need to set up anything. I'm giving you all the things, not only the application, as well as the libraries, the runtimes, the configuration, whatever you need in order to run that application in one package, and that I am shipping. That package is actually known as an image or Docker image. Okay, sorry. Docker image. So that package is actually known as a Docker image, and you can actually ship anything with Docker, right? So any application with Docker, and that's the exactly same thing. Now, if you come and see if what exactly I have done, so I have an application whose name is Easy Recipes, which is a Docker image, and I have kept it somewhere. We'll discuss where exactly I kept it. So I've kept it somewhere, and the moment I have just written the name of that location where my image is stored, immediately it just hosted that application, because whatever is needed in order to run that application, whether any runtime, any kind of anything, right? So anything that is needed in order to run that application was already present within that application, and we that's the reason why we didn't need to do any kind of complex setup in order to run that application. And that is what Docker does for us. Now we'll explain and we'll try to understand how exactly it does all the things. So first, in order to use Docker, okay, so as I'm saying, Docker is a containerization platform. What is a container and how it is different from an operating system or a virtual machine? Let's try to understand it. Okay. So first, in order to use Docker, you must have the Docker installed on your machine, right? So you must have the Docker installed on your machine. So if you look, what there is a software, if you are using Windows or Mac, so there is a software, Docker Desktop. Okay. So this is one thing that you need to download, right? So you have to go to the official website of Docker. You need to go to the official website of Docker and you need to download the Docker Desktop. Okay. So this is the official website. So which is not Docker Hub. I will just go to Docker. Okay. Installation. Okay. So if you go to, this is the official Docker, and here you can install Docker, right? So it is the Docker engine. So I would just go to Docker desktop installation, get started Docker. So this is the location where actually you can go and install, right? So I would share this share this along with you, so that if at all you want to practice, you can download. Let me tell you, this is a, you know, open source, and this is free. You don't need to pay anything. Okay. I would share this link later on, right? So I would share this link later on, or you can just Google it out and you would be able to download it, right? So, okay. So that's the thing, right? So chats are, for me, chats are disabled for now. So I would just, share this at the end of this meeting. Okay. So we just need to have this software installed on our machine so that I would be able to build my Docker images. Now, what is a Docker image and what is a Docker container? What exactly a container is? Let's try to understand. So, as I told you, a Docker image is a combination of the application as well as all the necessary runtime or the tools that is required in order to run that application. We combine all them together, and we we say that's a Docker image. Okay, that's a Docker image, and we later on we would be able to run that image. And I'm going to show you certain interesting things. So before we jump into the theoretical part, what is a container, what is an image? Okay, so let's try to understand some more thing practically, and we would understand the use case of Docker. Okay. One use case, we understood that it solves the problem that it works on my machine. It solves the problem because there is no difference between my machine and your machine, because the application isn't running on my machine directly. It is running as a Docker container. That means within a container. So let's try to, I will open my terminal to make you understand this. Just a minute.
Ramanuj.
Yeah, sure.
Actually, people are asking for the URL.
URL that I have already shared, but right now I'm not able to share it. Can you see that? I mean,
No, actually, I'm
it's
also not able to see that. At that time, I was facing some network error.
no, it's
Can you
saying
please?
that you cannot chat something it's showing.
Okay,
You
okay, now, okay, I got it.
please
I will
do.
share it with everyone. I will share it.
Yeah.
Done.
Okay. And again, another URL they are asking. Let me just check. This was also one thing that they were asking. So I will just share that as well.
Sure.
Yeah, please do share it as well, right?
Okay,
Anyway,
okay, okay. Thank you.
yeah. Okay, so let's actually start with it, right? So I'm having my terminal here and I want to check if Docker is installed on my machine or not. So what I can do, Docker -v. Okay, so it's going to tell me that version of Docker which is installed on my machine, right? So it's going to tell me the version of Docker which is installed on my machine, right? So you can see that Docker version 28.2.2, which is installed on my machine. Let me make it a little bigger so that everybody can see it more clearly, right? So we have a Docker installed on my machine. Okay, we have Docker installed on my machine. So all that I need to do, let's suppose I have an image. Okay, I do have an image and I do have multiple images and I'm going to show you. Let me run a couple of images. Let me bring these two together. Okay, so let me run a couple of images and one would be a Java application. Let me tell you, one would be a Python application. Okay, and one would be a JavaScript application. Okay, three different type of application: Java application, Python application, and JavaScript application. Okay, totally different type of application. And let's see how exactly I would run those applications on Docker. Okay, so first let's get started with the Java application. Okay, so let's get started with the Java application. There is a command Java minus jar in order to run that application, run Java application. But since we are using Docker, so we are going to use a Docker command, Docker run. Okay, Docker run, and I am going to give a port number. Let's suppose I want to run it on 8080. I hope the 8080 is free for me, and 8080. And I'm going to give a name of the image, right? So I would just write Ramanuj says slash k it is product app. Okay. So okay, it is product app, right? And let's write a minus. I will explain the command later on, right? So please just have a look on this right now. I would explain what is the meaning of this command, what is the meaning of each property that I'm passing here, right? Okay. Done. Let's quickly run that application. Okay. So, okay. So it seems the application is running and let's quickly check. So I would be checking my localhost 8080. Localhost 8080. Hit enter. And yeah, you see there's an application which is running, right? So there's an application which is running and I'm able to see that application, right? Okay. So there's a simple application which is running fine and I'm able to see that application. That's cool, right? That's cool. And this was how I ran a Java application. I would copy this command and I would save it somewhere so that I would be able to share this command later on. Okay. So let's just note it down. How did I run a Java application? Okay. This is how in case of Java, this is the command that I've executed to run a Java application. Done. Let's run a Python application. Let's run a Python application. Let's see. I'm going to run a Python application. Of course, I cannot host it on the same port. So I would just change the port right now here. Let's suppose 8081 and it is, I would give a different name. So that is a Flask, right? Python Flask application, Python app. And I'm going to write Flask app. So on my machine, I need to write, because it's an ARM processor, I would just write like this. Done. And let's have a quick look on the Flask app as well. So it is running on localhost 8081. Can we see that that's an hello from Flask app? That's a very simple, easy application. That's why I'm just getting hello from Flask app. Cool. And let's run a JavaScript application. Let me clear the console and let's run a Java application. Again, I'm going to copy the same thing and 1 minute. So I will just copy that as well. This is also required. I just copy and save it so that we can compare them. Done. And lastly, we would run the JavaScript application, right? So here only I can write and then I would paste it here. So let's run it on 8082 pod and let's give a different name. The name is Easy Recipes app and Easy Recipes. Okay. And I'm going to run this as well. Sorry. I'm going to copy and let's paste it. Done. And done. So even that is also running, which is on 8082, localhost 8082. Done. And you see that application is running. The just now we have, which we was running, we were running on GCP. The same application is running here as well. Okay. So you look at this, I'm able to run this as well. Okay. Now the important question is how things are running. And if you compare, right? So why did I write all the commands at one place? Now you can compare the difference. So the way we run, imagine you are not a developer, you are into the deployment, you are into an operations team. So the role of an operations team is to deploy that application, is to write all the necessary things in order to deploy that application, install all the, keep making the infrastructure ready and all such things. Now imagine you cannot say that I can deploy in the Java app. You cannot say that I can deploy only Python app. I can deploy only JavaScript app. I can deploy only, there are so many languages, tools, platform, frameworks are available. So you cannot say that. Now, the way we run a Java application, if you compare this, see, there is no difference. This command doesn't have any relation with Java. Neither this command has any relation with Python. So they are just, no matter what is inside, whether it is a Java application or a Python application or a JavaScript application or anything in this world, you have one common command to run anything. Docker run, and then you write whatever is required. Docker run command does everything, right? So Docker run command is the only command that you need to know as an operations person. You don't need to know all such things, how to run a Java, how to run a Python, how to run a JavaScript. And tomorrow a new technology or new language is coming, you don't need to learn that. That is what the benefit of having Docker, right? That is what the benefit of Docker, having Docker. So one problem it solves, that it works on my machine. Second problem it solves, that you don't need to know how to run different applications. There is one consistent way to run that application using the Docker run command. Okay, using the Docker run command. And let's try to understand what Docker run command exactly does. And let's decode this particular command that I have written. Let's copy this command and let's write it here to understand it. Oh, sorry, I guess not properly copied. I will just copy it again. Okay, so let's write here and let's decode everything with respect to the command. I would write it in multiple lines so that things would be clear. Okay, let me make it bigger. Okay, so this is how a Docker run command looks like. This is how a Docker run command looks like. First of all, what do? We write Docker run this minus p, right? So minus p stands for pod or publish, whatever you say, right? So pod, right? On which pod you want to run. Now you can see, why did I mention two pods? Why not a single pod? Generally, whenever I run an application, I run a single pod, but why there is two pod? That is what we need to understand. Okay. Docker is installed. Imagine this is your machine. On this machine, Docker is installed, right? So let's consider this is Docker. Okay, this is Docker, which is installed on your machine. And within that Docker, your applications are running. So maybe that Java application, a Python application, right? So your app is running within that application. You are trying, Docker containers are isolated from any other stuff. Every Docker container is isolated from any other container, right? So also it is isolated from your host operating system. This is your operating system, and you have browser. Which browser I'm using? Google Chrome. So you have a browser. It is your Chrome browser, and you are trying to access an application which is running on Docker. You're trying to access an application which is running on Docker. Obviously, you are not, right? So you won't be able to access it because this is isolated. This entire application is isolated from your operating system, from any other container. So it is running within that container. How exactly you'd be able to access? And that's where this P flag is used, which stands for publish. So I'm publishing it on which pod? Here I can mention any pod. I want to publish it on 9,000. I want to publish it on 8,000. Anything I can mention, right? So I can actually mention anything. For example, here I have mentioned 8080 or 8082, 83, and so on. So this is where I'm publishing, right? On the host machine. So I would, if I write anything, so I would write localhost. Let's write a different so that we can understand it more clearly. So imagine I have written 8081, right? So I would just write on my machine, I would type localhost 8081 to access this. So on my local machine or on my host operating system, that is in my case, it is Mac. In your case, it could be Windows, Mac, Linux, or whatever it might be. So you would be able to access this application on localhost 8081. You can publish it anywhere. And why did I write 8080 at right hand side? This is your container pod. So this is decided by the application developer. If I am a developer, I can decide that where my application should run. So within that container, it is running on 8080. And this is not in my control, right? So not in my control means not in the person, not in the control of the person who is actually running the Docker container, right? So that person isn't responsible. This is a fixed thing that I have decided, the application developer has decided. So I have decided to run my application on 8080. So it is running on 8080. Where I want to publish, that is my choice, right? So within Docker, it is always running on 8080. It depends on how did you write that application. So I written that application, that product application, or whatever it might be, that I mentioned that it should run on pod 8080. That is at my application level. Docker has nothing to do with that. Remember, there is no role of Docker in it. So that is a role of that is done by the application developer. He or she has created or mentioned that the application should run on 8080. Okay, so that is what. Second argument that I've passed is a detach flag minus D, which means you should be able to use the terminal. Okay, I would explain without a D so that you will understand what is the difference. And then I have given a name to the container. And lastly, this is the image name. Okay, so this is the name of the image. This is the name of the image. Okay, now how exactly we can run things? Okay, let me explain it a simple another example. Okay, let's first thing, if at all I want to run a container, I should have an image. Okay, so if at all I want to have a container, I should have an image. What is the difference between an image and a container? That's a very important thing. Most people get confused between image and container. Well, image is a template. Image is a template which has instruction what all the data, right? So the application, the runtime, and everything. And whenever you run that image, it creates a container. Whenever you run that image, it creates a container. Now, what is a container? Let's try to understand container very properly, right? What is actually a container? Many people get a lot of confusion with this name container and what exactly is a container. Okay, a container you can think of as a bare minimal operating system. Although it is not an operating system, let me clarify. But just for the understanding, for time being, you can consider a container is a bare minimal operating system which has everything in order to run an application. So there is something called a virtual machine, and I'm sure everybody is aware of what is virtual machine. So you have everybody is aware of what is a virtual machine. A virtual machine is actually a machine within a machine, right? So I this is my Mac machine and I have to run, right, for some particular task. I have to run a Linux operating system on, and I need to do something with Linux operating system. Obviously, I won't go and buy a new PC for that. So what I would do, right? So rather, I would create a virtual machine. Virtual machine is a machine that runs on top of the top of your operating system, right? So on Mac, I can install Linux or Windows or whatever I need, and I would be able to run. That is what a virtual machine is. Now, how container is different from a virtual machine? Okay. So when you think of a virtual machine is a very big, a full-fledged operating system which has its own file system, own networking, own you know process, own kernel or hardware, we can say hardware drivers and so on. Okay. Okay. So it has everything. A virtual machine has all of this. When if you compare with a container, right? So if I compare the same thing with a container, it is like it has its own file system, own networking, own process, but there is no hardware driver or there is no kernel. Okay, so we don't have any kernel. It uses the host operating system kernel. So in that case, container is very lightweight. Okay, it's a very lightweight thing as compared to a virtual machine. In order to start up a virtual machine, it takes some time. It consumes 10 times more memory than a container. It consumes 10 times more processor than a container. But a container is a very lightweight, right? So some MBs, like maybe 100 MB, 200 MB, maximum 1 GB, right? Maximum 1 GB, 2 GB it can go. But you see, a virtual machine would consume, right? So if at all you are running a virtual machine on your machine, right, it will take somewhere around 10 to 20 GBs of memory. It's bare minimal. It can be more, right? So if you think of a Windows operating system you want to run on your machine, only Windows file system itself will take some 10 to 15 GBs of memory, 10 to 15 GBs of hard disks. I mean, so that is not there with respect to a container. Also, in order to start a virtual machine, it will take some time, 2 minutes, 3 minutes, 5 minutes, but a container can start within seconds. So that is the difference. So container has file system, networking, and process, but it doesn't have any hardware driver or kernel and so on. And containers are way lightweight as compared to virtual machine. Okay. So we understood the concept, what is container and what exactly a container has, right? So let's try to understand practically. Imagine you are running, let's quickly do, let's run a container for maybe, I can I can run any application. Let me tell you, most of the application nowadays, if at all you want to run MySQL, Postgres, MongoDB, okay, everything has Docker containers. So you don't need to install most of the software on your machine. And in fact, I myself don't install a lot of software on my machine, right? I simply go and download the Docker container and run it. As simple as that. So one example I'm going to show you with MySQL. Okay, let's run MySQL. Let's run the MySQL without installing MySQL. So what I'll do, there is a simple command. First of all, I would pull the image. Let me write the steps. Okay, pull steps to run a Docker image. Okay, let's write the steps to run a Docker image. First of all, pull the image. I have to pull the image. So the images are stored in a repository, which is actually known as a official repository, which is known as Docker Hub. Just like GitHub for having your Git repositories, Docker Hub is there to store your Docker images. And again, Docker Hub is a free. You can use, you can create your account on Docker Hub and you can push your images or store your images on Docker Hub. Okay, so that is again free. This is an official from Docker. There are other options as well. We'll discuss about it, but this is the official. So pull the image. So first, what I would do, first I would pull the image. Done. Let's quickly pull the image. Docker pull. The command is docker pull and write the name of the image, right? So I want to pull MySQL. So you just write MySQL. Docker pull MySQL. Done. And look at this. It's going to pull that. Okay, so you can see it's going to download that. Okay, so it will take some time depending on the machine, your machine speed, but it is, I don't take much time. You'll see, right? Yeah, it is done, right? So we got the MySQL image. Docker pull MySQL, download the image for MySQL. Then I have to run the MySQL. Okay, so if at all I want to run MySQL, step two. Okay, so in the step two, run the MySQL. So in order to run the MySQL, I need some command. Run the image. Okay. If at all I want to run the image, I need some command. What is the command? Same, right? Exactly same command that we have used previously, docker run. Docker run minus p and exactly same thing. Okay. So let's quickly run this. Docker run minus p. Now, where you want to host MySQL, it is your wish, but where exactly MySQL runs? MySQL runs on 3306. This is something that everybody knows, right? 3306 colon 3306. Okay. So I'm taking MySQL and I'm hosting it on port 3306 on my local machine. This is the container port. This is the host port. Just now we discussed. Okay. Minus D. We can write all these things like all these things are not required. I will just reduce a few things. Okay. This is not required for now. You can just remove. Okay. So minus p name will just, you can give any name, right? So you can give MySQL container. Okay. MySQL container, and I have to pass a MySQL initial password. So I have to pass as an environment variable minus e MySQL root password, and let's give some password. And lastly, I have to write MySQL, which is of course the name of the image. Okay. So if I hit enter, I would copy this command obviously, and will share with you as well. So if I hit enter right now, you can see that I got a response. That means the MySQL container got started. Okay. So this is the command to write run MySQL. Pretty much the same thing that we have done previously, almost same command, just that we had to pass one extra argument because MySQL demands that argument. You have to pass that argument. Then only you would be able to run MySQL container. I would share all the commands that I have written. Don't worry. Okay. So you have this right now. With the help of that, I'm able to run the MySQL, and actually MySQL is running. Okay. How would I check what and all containers are running on my machine? How would I check? So there is a simple command, docker ps. Docker ps list all the running containers, and look at this. What and all containers are running on my machine? One is, MySQL container, Easy Recipes app, Flask app, product app. These are the containers which are running on my machine, right? So it's pretty simple. Docker ps, if you run this command, it will show all the containers which is running currently. Similarly, if you write docker ps minus a, it will show all the containers irrespective of whether they are running or not. So you would be able to see more containers now. See, there is a container called Mongo, which is, there is a container called Minikube. Okay. So which are currently not running, but yes, they are there on my machine. Similarly, if you want to see all the images that are present on your machine, so I have pulled MySQL, I have pulled many other images. So you can type Docker images. If you type Docker images, you would be able to see that, yes, I do have, these are the images currently available on my machine. So there's a product app, MongoDB image, MySQL image, Flask application, Easy Recipes application, right? So Minikube, uh, you know, image, many multiple images. So I would be able to see those images. And if at all you want to stop, right? Let's suppose many applications are running on my machine. Easy Recipes is running, that Flask app is running, product list application is running, and also MySQL is running. So if at all I want to stop any of this application, I can definitely do that. I can write Docker stop and write the name of the container. So if you give the name like Flask app, done, it will stop. You see, the application would get stopped. Okay. So the moment I write Docker stop Flask app, it will stop that. You see, you will get Flask app, the name of the container in return. So that got stopped. And if I come and if I try to refresh it, make it a little bigger. And if I try to refresh it, you see it's not there. So I stop that container. Okay. I can start it back. Docker start. And again, if I come here, if I refresh this, yeah, I'm getting it, right? So it's that simple. So I can, at any point, I can stop it, I can start it. Now, I am not running the run command again because the container is already there. It is created. Thus, it is not running. That's why I need start command. If I delete the container again, obviously I need to make the run command. Okay. So if I delete the container, how do you delete a container? Even if you stop the container, container would still be there on your machine. But if at all you wish to delete that container, container permanently, you can just write docker rm to delete the container. Docker rm. If you write docker rm and look at this, right? So the container got deleted. Cool, right? So you would be able to delete that container as well. So you can create a container, you can delete a container, stop a container, anything that you can do, right? So right now this container is deleted, and obviously if I write a docker start command, it's not going to start. It will give me an error. You'll see that error response. There's no such container. So in that case, what I need to do, I actually need to create the container once again. How do you do? Which command? Which command we use to create a Docker container? Docker run command. Isn't it? Docker run command. So far what we have seen, we have an image, and that image we can run as a Docker container. If at all you want to know a little bit more in depth of what, I cannot go right because we have a very limited time, but if at all I want to give you a very brief, in brief, or a glimpse of what exactly a container is, let me explain. So this is my Mac operating system. You can see this is my Mac operating system. And if I write uname, there is a command called uname -a, and you will get to know that what is that. It is MacBook Pro, and you'd be able to see the kernel version and all such information, right? So this is my Mac operating system. Okay, done. Now I would get inside a container. There are multiple containers are running, we have seen, right? So how do you see? Just now we have seen docker ps, right? So let's write docker ps. So imagine any of this container, maybe easy recipes container, maybe any other container like product app container or anything. Let's get inside the product app container. Got it? So let's get inside the product app container. What is the name of the container? Product app. Remember that? And I'm going to use that. So let's get inside a container. How do you get inside a container? You just need to write docker exec exec -it. It stands for interactive terminal. And then you have to write the name of the container and a command. So I want the bash command. Docker exec -it. You don't need to learn all the commands and so on right now. Just understand. I just wanted to make you understand what exactly there within a Docker container. I went inside this container. Now I am inside the Docker container. I am no more inside my Mac machine. Let me confirm that. Now, if I write uname -a, what you can see, it's a Linux, right? So it's a Linux operating system, right? So it is not my Mac operating system. You can see it is not showing my information on my Mac. It is a Linux operating system. And if I write an ls command here, you'd be able to see that I have something called app.jar. I told you this is a Java application. Product app was a Java application, and definitely I have a jar here. And if I go a little bit back, I would be able to see all the Linux file system. So you can think of, as I told you earlier, you can think of a container is a bare minimal Linux operating system. Although it is not like an operating system, as we have already discussed, an operating system has a lot of things which container doesn't have, but you can think of it as a bare minimal and a very lightweight Linux operating system which has a file system, networking, and a process. okay, which has its own file system, networking, and process. And exactly like that, right? So we have all these folders that are present in a typical Linux operating system. Same is there. And in fact, this container, since I told this is Java, I'm running a Java application. If I run this Java minus jar, sorry, minus version command here, you will get to see that Java is installed. Okay, so OpenJDK version, this is installed on this particular container. Again, let me tell you, this is not coming from my machine. My machine, if I show, I have a different version of Java installed on my machine. Okay, so let me show you. This is my machine terminal. If I write Java minus version, you'll be able to see that I have a Java 24, JDK 24 is installed on my machine. But this is the container. Okay, this is the container. Within the container, this is installed. Let me go back, exit from here. Okay, fine. Let me get inside another container. Flask app, is it running? No, it is not running. Let me start it once again. So let's use the command previously we have used. Docker run, is it one? Is it the one? Yeah, this is the one, right? So let's run the Flask app again. I am seeing that lots of chats are there. Okay, I would respond to your chat. Okay, I would discuss about all the chats, all the things that you are saying. Okay, um, all the question that you are asking, right? So, well, we have a Docker run command, you see, and I'm running this Flask application. Let me get inside the Flask application. How do you do? Same command, right? So Docker execit Flask app, Flask app bash. Done. And here, what I would do, let's run again, you name minus a. You'll be able to see that again, it's a Linux operating system only. And if at all you want to see, you know, if you type Java minus version, what we will get in return is Java command not found, because that's here in this container. I don't have Java. Rather, I have a Python. If I type Python, okay, Python or Python 3, I guess, Python 3. You see that Python terminal open. Okay, you see that Python terminal open. Let me exit from there. Okay, so this is again, if I do a CD and if I write ls, you'll be able to see similar file structure and everything. So you see the previous one, what we have, same thing. Similarly, here also we have same thing. So every container is a self-sufficient, right? So it has everything in order to run your run your application, right? So if you cd, if you go to the F folder and if you write ls, you'll be able to see that there is an app.py file. Same thing we have seen previously, it was having an app.jar file. So every container would be having its own things, like whatever software that you are running. If you're running a Java application, you would have the Java and all such things. And interesting thing is, I can actually install any other app. I can actually install Java within this container, and it's possible, right? So we have seen that when I write Java minus jar is not there. I can actually install Java within this container as well. So if I want to install Java, can I do this? Of course I can, right? So I can write Java, uh, you know, apt install Java, right? So we can just write apt install Java, apt update minus y, and then apt install Java, apt install default JDK minus y. Done. And okay, it will take some time. Look at this. It's going on. Yep, it's done, right? So if I clear everything and if I write Java minus v, I'm sorry, Java minus version. Okay. Look at this. JDK 17 is installed. Can you see that? JDK 17 is installed. We got installed JDK 17. So it's the same container which is Python. Now I have installed Java within it. And in fact, I can install any software in this, right? So if at all tomorrow you want, okay, I want Git, I want Maven, I want something else, you can literally install anything in this. It is, as I told you, every container, if you think of any container, has its own file system, networking, and process. So you can install anything, you can run anything as a process, and it has its own networking. The only thing that you won't have, it's its own hardware, own driver. These are not there, own kernel is not there. Apart from that, you can treat it just like an operating system. You can treat it just like an operating system, but it's a bare minimal and it's a very lightweight. That's the best part. Okay, so we got to know a lot of things, and let me quickly have a look on your questions also, because questions are keep on generating, right? So I can see a lot of questions. Okay. um okay, so one question is, okay, uh how
Uh,
can, yes,
I can read those questions for you.
okay, sure. Yeah,
Okay.
so one question is, how do we decide port numbers? Well, this is an application developer's wish, which port they want to run on their application. But which port you want to publish, it is again your wish. There is nothing like a decision or something, but it varies. Like if you are running a web application, it makes a lot sense to run it on a port number 80 or 8080. If you're running, it depends on, depending on the type of application that you are using. uh, so it varies, right? So there is no hard and fast rule, it is your wish. Second is, what is the difference between Docker and Docker Compose? Okay, so Docker Compose, I'll show you Docker Compose as well. That's a good question. So what is Docker Compose? When you have multi-container application, right? So then I can use Docker Compose. I would show you an example as well. Let's suppose all these three containers, I have Flask app, uh, Easy Recipes application, my product app. I want to run all of them with one command, stop all of them with one command. I can use Docker Compose. Got it? So that is what Docker Compose is. Third is, okay, so this image we can directly download or need to create it. See, all these images that I am using here, you can directly download. Some I have already created and pushed it on my Docker Hub, and some are official images. How do you understand which are official images? So whenever I use this command, okay, I have written, you see, Ramanuj. This is my Docker Hub user ID, right? So this is my Docker Hub user ID. And if you see that any image I'm running without using any, image name, I'm writing directly without using any user ID, that means it is a official Docker image. So MySQL is an official Docker image. So it doesn't need any ID, like you don't need that, right? So that's an official image which is available on Docker Hub. This is an image that I have created and I have published, and it is public. That's the reason why everybody can use it. Similarly, all these images that I am using, you'd be able to see that my name is associated with that, my Docker Hub ID is associated, because these are the images that I have created. Okay, cool. uh, how can we host different website with the same container pod? We did host Python JS app in 8.0.0. Okay. Every container is isolated. So this one is running on 8.0.0. Again, another container has its 8.0.0, and another app like Python, consider. Similarly, I have run another application. So imagine this, for this application, this container is only the whole world. It doesn't know what is there outside. It doesn't know what is there outside. So within that container, you can use 8080 or any port and you want, because it has nothing to do with what is there inside another container. But while hosting, or while publishing it on host, I use different port. You see, here I have used 8081, here I have used 8082, but they all are running on 8080 within the container, because within container, what is there in one container, other container will never get to know, right? So they are not connected to each other, all are isolated. That's why i can run I can use the same port across container, there is no problem. Okay, so that's the answer of your question. Okay, then you have these images we can directly download on it. Okay, I answered that question. If Okay. Can you install two applications in a single container? Well, practically we can, but we won't, right? That is, one Docker container is meant to run one single application. Practically we can, and if we do that, so what, there won't be much need of using a container. See, what we are trying to simplify is a container, you know, running a single application and making it lightweight. If you have to run multiple application, it makes sense to use different containers. You can practically run multiple. Just now I showed you, right? So you can install Java also within that container. You can install another thing also within that container, but which will make that container very heavyweight, and the primary goal of using that container will lose. Okay, that is the point. And how DevOps and developer use Docker? Yep, that's a very good question, and I would show you with the pipeline that we'll create there. You will get, right. Is there any loader balancer? If we hit 800, then it redirect to different container. Uh, See, your question is like, I think it should be load balancer anyway. So load balancer, if we hit 800, then it redirect to different container. We can create some rules if at all you want. And, if it starts with /app, then go to this container. If it starts with that, then go to this container. We can do that. It is possible, but we have different concept to do that, right? So there is a, component called ingress. See, Docker, it's all that Docker is providing is running a container, creating images and run the container. If you want to do more with Docker, if you want to use advanced capability, right? So you are saying about load balancer, which should do auto, depending on what you are writing, depending on the URL pattern, it should automatically switch to the right container or the right application. Yes, we can do that, but for that we need to use something called ingress, which is a component of Kubernetes, ingress. Okay. So Docker cannot do everything, but if at all you want to achieve a lot of things with Docker, you need to learn more tools, right? So you have to, after Docker, you have to learn Kubernetes so that you can make the most out of Docker. Okay.
Sorry to interrupt. Actually, we have one session feedback form, which I'm going to launch. I would like to request everyone, guys, please do fill it out. With this, we can continue a Q&A.
Uh, yeah, we have another topic which is remaining, which is where I am going to demonstrate how exactly you can set up a CI/CD pipeline to deploy an application on any cloud platform like this Docker image. How exactly I can do. But before that, let's try to understand how do we build a Docker image. That is also very important, right? So we should know how to build a Docker image. As of now, what we have done, we have some Docker images, and we actually run those images. Those were ready-made images. How about building your own image? Okay, how exactly you can actually build your own image. So think of it, right? So you have a simple Java application. Let's build one. I would use my IntelliJ idea, and so I'm going to create a simple project on IntelliJ IDEA. Just a minute. Which one is not a full screen app? Okay. I'm going to create a very simple application, a Spring Boot application. It doesn't matter whether you know Spring Boot or not. It's absolutely fine, right? So I'm just create a simple application, my Spring app. Okay. So let's give a name like my Spring app, and let's create it on a particular folder. Okay. Let's create it on a particular folder on my machine. Let's go to playground. Okay, done. Cool. And let's give an some name, right? So com.springboot app makes sense. My Spring app. Okay, everything is fine. I would just use Maven, and Java 17, everything is fine. Let's click on next. And I would use a library called web to create a REST API. As simple as a very simple task that I'm doing. Okay. So if you don't know about this application, it's absolutely fine. There is no need. Okay. Same thing I can demonstrate for a Python application also, which is already there, I would show that as well. Okay, so let's create this application. That application would be loaded here, and I'm going to show you. Just a minute, let me bring it here. Okay, so there's an application, and this is the application, and I would just create a controller. I mean, I would just create an API here to say something, hello world, maybe, right? So here I'm just creating a simple Java class. Let's suppose grid controller. Done. And I would just say hello world. Very simple thing, right? So let's write there is a REST controller, and I would say at get mapping and git grid, let's say hello world. It's as simple as that. There's a hello world application, and I can actually run this. So this application by default, whenever you start a Java application, by default what happens, it runs on port number 8080. Of course, you can change. If you want to change, you can come to application.properties and you can just write server.port equal whatever you want, right? 1000, 80, 85, anything. So by default, it runs on 8080, and I'll keep it 8080 only. I don't want to make any change. Okay, done. So this is the application, and which is running on 8080. That's cool. And I can run that application, but there's a problem, right? So already, in actually Docker container is already running on my 8080 port. 8080 port is already occupied, right? So localhost 8080. You see there is a port which is already occupied, right? So what I would do, I would stop that application, right? Let's go to the terminal and okay, Docker stop product app, which is already using, I'm sorry, stop spelling mistake. Done. So I just closed it. Now if I run, you see, if I run this application, this is a simple application. As I'm saying, this is a simple application, and run that application, I'll be able to see the hello world. So the application got started. Yes, the application started. And if I write localhost 8080 right now, you'll be able to see that hello world is getting printed. Cool, right? Hello world is getting printed. Now, how would I build a Docker image out of it? Okay, how would I build a Docker image out of it? So, well, in order to build a Docker image, you need to know, as I told you, what exactly Docker image contain. Let's understand what exactly my Docker image, any Docker image actually contain. Okay. So if you think of a Docker image, what exactly it has? I told you already, any Docker image consists of the application as well as the runtime that is required in order to run that application. So first of all, I would build that application. Okay. I would build that application. The way I can build that application is by running a command Java, or by running a mvn command. So there is a mvn command, or I can directly write it here, mvn. Okay, let's open the terminal, and I can actually run a command mvn package. Okay, so mvn is not installed on my machines. No problem, I'll do it from here, from the ID itself. So I would just go to the life cycle, and there is an option called package. I'll double click on this, and it will create, you will be able to see that build success. Okay, you can see build success. Now with that build success, you got a target folder, and in this target folder you got a jar file. Can you see that? My spring app blah blah some name, right? .jar file. Okay, so you'll be able to see that the jar file name. If you don't want that complex name, you want a simple name, of course you can do that. I would just do that. Okay, because I don't want that big name. I don't, because it is required for my CI/CD pipeline. So I would give a simple name. So there is something called final name, and I would write this project dot artifact ID. Done. So what is the artifact ID of this project? My Spring App, right? So you'll be able to see that the artifact ID is My Spring App. So now the jar file would get created, would be, the name of the jar file would be My Spring App, right? So let's remove the existing jar file, and then let's create a new jar file. You would be able to see that there is a very uh, simple name, and you see my spring app dot jar file. That's the jar file that I am having right now. My spring app dot jar file. Cool. Now what I'll do, I want to run that application. In order to run that application, what is the command? If at all I stop this application and if I want to run this jar application, okay, I'll open the target folder. Okay. And if at all I run this, I have a command, any Java application, there is a command java minus jar. Okay. And the name of this, my spring app dot jar. So the moment I hit enter, you see the Spring Boot application will get started, and I will be able to access this application on this local host, 8080 again. You see it is running. Let me stop it. Done. So I know the command to run that application. I know what is required in order to run that application. Plus I have that application. All combined together creates a Docker image. All combined together. Remember what happens when I combine all of them together? It creates a Docker image. Done. So let's combine them together. And in order to do this, I need to write an instruction. Okay. I need to write an instruction to do all these things. Okay. So if at all I want to do all these things, I need to write some instruction. What is that instruction? Well, that instruction that we write using something known as a Docker file. So we can create something which is known as a Docker file, and we would run everything, or we would create our Docker image using that Docker file. Okay. So let's quickly go to that and let's quickly run that. Okay. Let's quickly run that. Let's quickly create that. First thing that I would create is a Docker file here. Right? Docker file. What is a Docker file? Docker file is a text file which has an instruction on how to build a Docker image. So I'm going to create a file whose name is Docker file. No extension. It's not dockerfile.txt or something. D should be uppercase, and this is what, right? So this is how a Docker file looks like. And in this Docker file, we are going to write what and all things my Docker image should contain, right? So what and all things my Docker image should contain, that is, I'm going to write it here. Okay, that is what I'm going to write it here. So first, let's get started with a Docker image. You can create from an existing image. Let's suppose you have an existing image and you want to create, as we have discussed. So imagine you can write here from Ubuntu. So you are considering the base image of Ubuntu. On that Ubuntu, you can actually run a command apt get update, apt get install, right? So like this apt get update and then apt get install, not Python 3, we'll just write openjdk, right? Or Java. Okay, let's write JDK is there or not, right? So openjdk, yeah, or OpenJDK 17, right? JID headless, and if at all you want to install anything else, right? Install wget, right? So you see, these are the things you can do. You can install Java and all such things, and then you can actually run your application. After you install that, then you can actually copy, right? So you can copy your jar file, right? Copy the jar file, whatever within the target.jar file, right? Target slash dot jar, okay, to a folder called app.jar. What and all things and you can do. But since you don't need to do so much of things, because you already have the jar file, you can run the jar file. All that you need to have a Docker image which already has Java installed. Okay. So there is an official image. I don't need to do all such things. I don't need to take an Ubuntu and I don't need to install all such. Somebody has already done it for me. And there is an image. There are so many images. You can go to Docker Hub and you can search for an image that has your desired version of Java installed. For example, in my case, I always use, there is an image called OpenJDK. Okay, OpenJDK. In my case, I will use the latest one, OpenJDK 21 hyphen JDK hyphen slim, right? So this is a very lightweight image that has already Java installed in it. So imagine there are lots of layers. So somebody has might have used Ubuntu and then done as the installation and then published this as an official image of Docker, which I can use. In fact, I can also use my old images as well. What if I write from Ramanuj and this? Absolutely fine. This is also okay. I can write this. You know why? Because we have seen this image already have Java in it and I can use. So I can use any of the existing image that has Java already installed, or I can use an image like Ubuntu. I can manually install Java in it. Your wish. Obviously, it makes sense to go with this. Okay. Rather than going with my previous image, it's an official image. I will go with that. On that, I can just write, let's set the working directory. So it is your wish. You can set it. I will just write work slash app. So it will create an app folder, and on that, all my commands will run. So next, I will just write a copy command or an add command. Anything is fine. So I will just write add. Okay. Add target. Okay. Slash dot, you know, or star dot jar. We can write dot jar. We can write. So I'm saying that any name, or I can just write my spring app dot jar. So it is building an app called my spring app. Makes sense. My spring app dot jar, and where I'm going to deploy it, or where I'm going to save it. So I'm saving it as an app.jar on my local, on my within my Docker image. You can keep the same name, any name your wish. So I'm just giving a simple name app.jar. And when I run this application, what I need is a command. So I can just write cmd to mention the command. So we know that all that we need to know right in order to run that image is Java minus jar app.jar. We have seen that right now. We have seen that, right? So if at all I want to run this image, I need to run this. Why I'm just writing only app? Because within that container, I'm saving this file with the name app.jar. If you can use the full name also, your wish, done. So this will run that image. Optionally, you can write expose 8080. It doesn't mean that it doesn't, even if you write expose 5000, still your application will run on 8080 only, because this just tells the user that your application will run on 8080. Actually, it doesn't, expose doesn't mean that it will run on 8080. It is just giving a hint to the user. Whoever is going to see the Docker file, he will get to know, okay, my application is going to run on 8080. And it is a good practice. You should write it. It has no impact on your image creation or on your application run, but the user or the DevOps engineer or the operation person will be, after seeing this Docker file, will have an idea, okay, the application actually is going to run on 8080. Done. I would save all these things. So that is the instruction that I need to save. And all that I need to do is to run a command docker build. Docker build. Oh, sorry. Docker build minus T to give a name. Okay. And let's give a name. What is the name? Like my spring app. My spring app dot means on the current folder, look for the Docker file. Actually, this will fail because I am on the target folder right now. I would, you know, cd go back. Now I'll write docker build minus T. Okay. Then my spring app dot. Okay. Docker build minus T my spring app dot. Quickly. And look at this. The image will get created. Yes, it got created. And if you look at the Docker images right now, if I run this command Docker images, you can see my spring app I got, right? So my spring app I got. And if at all I want to push this as well, I can do, right? So I just need to tag it, Docker tag, name, you know, the image, which is my spring app, and you can write with my Docker Hub ID slash my Spring app. Okay, my Spring app done. It will do. And then I can actually push Docker push. Done. And you see it is getting pushed, and you can now, after push is successful, you can actually write Docker pull and my Docker Hub ID and my Spring app. It will actually download. That got pushed. It is that simple and straightforward. So I build that Docker image. Once I build that image, there is no relation with the Java, Python, or anything, because as I told you, it has everything. I've already given the jar file. I'm having an Docker image with Java install and everything. Everything is ready. All the commands to run that application. All that you need to do is to Docker run command. That is your job. Nothing else. You don't need to know that what is there inside. You don't even need to know whether it is a Java application, Python application, or whatever it might be. And that is the magic that Docker does. Now, I hope you got a clear idea of what Docker is doing. Okay. So I hope you got a clear idea of what Docker is doing. And, you know, let's quickly do one thing. Let's create a CI/CD pipeline to do the same thing. In fact, the interesting part is the application that I've created by default, I can connect it to an CI/CD pipeline. Where did the application is running? Sorry. Here, right? By default, Google Cloud has a very nice way, right? So I can connect it to a repository and it will work. No doubt, right? But I am not going to do that. See, connect to a repo. Just that I can click on connect to a repo and automatically it will do all the CI/CD pipe stuff within one click. Okay, within one click, it will do without writing even a single thing, any single script or anything. This GCP has that great features, but I'm not going to use that great features right now, because as we are supposed to explore, as we are supposed to explore um, that GitHub Actions as well. So what is GitHub Actions and what exactly we need to do with GitHub Actions? So GitHub Actions, just like other CI/CD tools, like we have Jenkins, we do have GitLab CI. GitHub Action is one of them, right? It is from GitHub. So we are going to implement the CI/CD, which is continuous integration and continuous delivery or deployment using GitHub Action. So what are the steps that I need to do? First, I have a Java application. So what I have, let's suppose there is a developer here who is writing his code, right? So we have, do I have a symbol of human? Yeah. So there is a developer who is typing code on his machine. And as soon as he make any changes, right? So he make any commit or push, so there is a centralized Git repository. Okay. You can think of this Git repo. Git repo or GitHub repo, whatever you can say, GitHub repo. To be very specific, GitHub repo. So whenever that person is pushing any new code, any changes, right? So whenever that person is pushing a new code, what I want that automatically all this stuff should be done. I don't want to manually build the jar file. I don't want to manually build the Docker image and then pushing the Docker image, pulling the image. Lots of things are going on. I want to automate the same thing that we have done right now manually. I want to automate that task. Okay. And that's where I'm using a pipeline or CI/CD pipeline. And the tool that I'm using for it, GitHub Actions. I can do the same thing with Azure DevOps. I can do the same thing with Jenkins. So many options are there. GitHub Actions is one of those options. Done. So once I push, what has to be done? The code has to be pulled, and I need to build from that. I need to build a Docker image. Okay. Pull, build Docker image. I can run all the other things if at all I want to run some testing and all such things I can do, but I want to simplify this step, right? So I'm not writing too many steps. So build a Docker image, then push the Docker image. Done. And lastly, deploy it on cloud, right? So deploy it on Cloud Run. I mean, the service that I'm using is Cloud Run. Deploy it on Cloud Run. Okay. Cloud Run is what? Is a service by GCP, which the similar kind of services they are on Azure as well and AWS as well, right? So that's the thing that I want to, that is something that I want to implement. I want to push my code. As soon as I push my code, the code has to be pulled, then the Docker image has to be built, the Docker image has to be pushed, and then it should be deployed on the Cloud Run. Let's quickly start the step. And how do you do this? The first and the most important thing, I would create a Git repository for this. So let's quickly create a Git repository. I'll go to my GitHub and let's create a new Git repository. Okay. So let's create a Git repository. Let's give a name, you know, um, Spring Boot Cloud Run or Spring Boot Docker CI/CD. I'm just writing something, right? So Spring Boot Docker CI/CD. Just remember this name, Spring Boot Docker CI/CD. Okay, and let's create this repository. Done. And I'm going to clone that repository on my machine, right? So let's quickly copy that link, and I'm going to clone it. So I am already on my terminal. Let's go to a proper folder. Okay, git clone, and let's paste it. Okay, so I cloned this repository. Done. So what I'm going to do, I'm going to, which terminal you are saying about? This is my machine terminal. This is your, if you are using Windows, that is command prompt for you. Okay, so that's, you can do on your machine as well. So you see, I have this git clone done. I have cloned this repository. Cool. And what I'm going to do, I'm going to copy all my code, the code that I've written on that repository. So whatever code that, not everything is important, right? It's only SRC file, Docker file, and the POM XML. Remainings are not required. So we'll just copy these three files in that particular folder. So let's actually open that folder. Okay. So let's actually open that folder, and I would find it on my documents playground, right? Playground. And right now I've just cloned it, right? So Spring Boot CI/CD, Docker CI/CD, right? Okay, so let me paste all these files. Docker file, POM XML, and the SRC. Done. All these three are required. I would slightly modify my Docker file. Okay, let's open the whole thing you on IntelliJ IDEA itself. It's better. It would be easier for me to edit, or I can use the Visual Studio Code as well, right? So if at all I want, right? And anything is fine. It doesn't make any difference. This thing or that thing. So I'll just open. Okay, open documents, right? Where it is, documents, playground, my Spring App, right? So I would, not this one actually. Spring Boot Docker CI/CD, this one, right? So let's open that. I'll open it on the same window. Done. So from here, I can easily modify, but the files are not loading. I mean, it's taking some time. I don't know why it's taking time. Maybe a lot of things are running on my machine, which is creating it. Um, it's taking, that's the reason why it's taking time. So I would do one thing, right? So right now, I don't actually need Docker because that we are running it on GitHub Actions. So I would just quit the Docker, which will save some of my RAM. Okay. IntelliJ IDEA is not properly loading. Okay, no problem. I would open it on VS Code. What is the name of the Spring Boot Docker CI/CD? Okay. CD and code dot. Okay. So Visual Studio Code will open in this. And I'm okay with anything, right? So whether, doesn't matter whether it is Visual Studio Code, whether it is anything else, because IntelliJ IDEA is having some issue. I don't know what is the issue. Maybe. Okay, cool. So I have the same thing, right? Okay, how come? Yeah, okay, you can see that. So we have the same thing, POM XML, SRC file, and so on. So I'll slightly modify my Docker file. I would do all the write all the step within that, right? So I would do all the steps within that rather than separately building, because this needs additional step. This needs that jar file should be already there. What if I have a Docker image wherein I'll copy all the POM XML SRC file and build the jar file within the Docker itself? That would that would be better, right? So I don't need to do in my CI/CD pipeline. I don't need to add this extra step for here. I'm just directly building the Docker file. Otherwise, I have to build the jar file as well. Build the jar file. Then after jar file, I have to. So this step I'm combining together within the Docker, you know, Docker file. Can we do? Of course we can, right? So we have all the way to do anything. Here we can install Java, Python, anything that you want, right? So you can write all the instruction. And exactly the same thing that I'm going to do, which will save my time and as pipeline step as well. So what I would do, right? I just need to modify, not OpenJDK. I would, because in order to do that, I need an image with Maven install, and there is an image. So there is an already built-in, script. Docker file is already there. I will use this because if I type, already we are running out of time, so I cannot type a long thing right now. So quickly I would just uh, take that Docker file, okay, and I'll use this from some of my repository. Okay, so let's quickly do that. Let's save this, right? So build stage, we are going to run using this image which has Java installed, okay, Java and Maven installed, and I am doing this mvn clean package to build that jar file. Secondly, what I'm doing, finally, same thing, just copy thing, whatever we have done, right? So exactly the same thing, app.jar and all such things done. So this would solve the problem. This is the Docker file that I'm having. Cool. So I got the Docker file. I got this. Now I would push my code, right? So let's quickly push the code from here or from terminal. Anything is fine. Okay. So I would just see changes, the Docker file, the POM XML. Uh, I don't need all the files. Okay. My Spring application, too many files are going, which of course I don't want. State changes. I don't want this work. Yeah, extra files. Let's see. Okay, fine. All the Java file and everything I would send, right? So these are not required. Target. These are not required. These are not required. Only the application properties, the Java file, and the POM XML file and the Docker file. Done. That's enough. And I would just push all these things. So, you know, uploaded the app code. Done. Okay. Let's commit and let's push. Okay. So commit is done. Let's actually push that. I believe it got pushed. Let's cross check, right? So I would just go to my repository and cross check if it got pushed or not. Let's refresh. Yeah, the code push, right? So all that I pushed is SRC, Docker file, and POM XML. Got it, right? So these are the three things that I pushed. Now what I'll do, I would write a workflow in GitHub Action. The CI/CD pipeline script that we write, that is known as workflow. So I have to create a workflow. Before I create the workflow, where to deploy, let's set it up, right? So let's create, uh, let's create a service on GCP, on Google Cloud Run, right? So we talked about just now, right? So on the Cloud Run, we'll create a service. Where is that? Cloud Run here? No, here. Yeah, that's the Cloud Run. So I would I'm going to create a service. Already we got a service, right? So easy recipes. I can use this, but that's not the right name. I would give a new name and we'll create a new service. Let's create a new service. Okay. So create a new services. Okay. And create service. This is an option. And in this, two things I want. One service I want to create, and somewhere I want to deploy my containers, right? So one is Docker Hub, which is official. Apart from this, Google has its own, which is known as artifact registry I can use. Similarly, AWS has its own called ECR, Elastic Container Registry. So which are alternative for Docker Hub. So artifact, but GCP, the best part is GCP supports both Docker Hub and artifact registry. I can use both. Okay. So I would go with artifact registry, which is a part of the GCP itself, and which would need lesser step to do authentication and authorization. So for time being, let's just deploy a demo container which is already there. Just to create the service, we have to deploy something. That's the reason why I'm deploying. Done. Let's give a name to this service. My Spring app service. Got it. And let's deploy it somewhere, right? So US, you know, central US central one, right? So you can deploy it anywhere, allow public access, done. And anything else I don't want, let it be, right? So you just create that. Okay. So the application will get created. This is where the application is getting created, and you'll be able to access this application. This is like a demo application, right? So you'd see this is a demo application. It's saying that it's running. Now I want my pipeline. I want to build a pipeline that should run that application on this, that should deploy that application on this. So what I'm going to do for this, I need to, first of all, I need to push that up inside my steps. If you look at the steps, I have an build Docker image. Okay. Then push Docker image. So if at all I want to push the Docker image, what I need is to have a place where I can push. One is Docker, one is, as you know, right, the Docker hub. Just now we have seen. Apart from this, we do have an option artifact registry. Let's quickly create an artifact registry as well. So this application is running cool. I would create search for artifact. I'm going bit quick right now because I have to finish it. Okay, complete this, right? So create a repository, type is Docker, and you can just write my Spring app. Okay, anything, right? So remember this name, which should be useful right later on, right? So my Spring app, cool. Region, you can create it on any region, but I would use the same region. Done. That's all right. So I don't need to do anything else, and I'm happy. Just click on create. Just remember, name is my Spring app. These names are very important, which should be used later on. It's somewhat, yeah, done. So here I would deploy my application, right? I mean, I will deploy my Docker image here. And right now I'm going to write a pipeline script to do all the stuff. So in order to do all these things, first of all, I need some authentication and authorization. And for that, I need to set up the project name. Okay. Let's quickly go to my GitHub and let's do a setting. Right. In this setting, I have to go to secrets and variable. Okay. And I have to set up, I would go to action, and within action, I would set up this new repository syntax secrets. Okay. So one name, I'll give that GCP project ID, and I'll copy the project ID from my GCP, right? So this is my training project. This is the project name, and the project ID, I would get it here. Okay. So if I open this, okay, this is the project ID. I can copy it from here. Okay. So this is the project ID. I would copy and I would write it. Done. Okay. Second thing is I have to copy and paste my, in order to access the Cloud Run service or any GCP service, I need a service account. So service account, I would write the name is GCP SA key, and I need to download the service account. So which you can find if at all you want to do the service account thing that you would find. You have to go to service accounts. From here, you have to IAM and admin. You have this service account option, and from this service account option, I have two service accounts. So any of this service account, the default one you take, and you would go and download the key, right? So you would uh, go and create a key, right? So create a key to access or download the JSON file of the key. So there is a key and I already have a key. You can create a new key and download it. So add key and create a new key, and you can download the JSON file. That JSON file content you have to open and you have to copy. And after copy, you have to paste it here. So which I'm going to do right now, which already I'm having the JSON file on my machine. I would just quickly open that JSON file. Okay. This I am definitely I'm not going to show you because this is uh, this is a secret thing, right? So just give me 1 minute. I'll do it and then I'll share it with you, right? Because that's the key. With that, you can access my uh, GCP account. You can create content and all such things, of course. So that's the that's the idea. So just anyway, the key. Okay. Okay, I'm not able to find the key. No problem. I'll download it again. Right? So just give me 1 minute. I'll do the download once again. I lost that key or I might have deleted. Not a problem. I'll create one more. Huh. It actually got downloaded and I'll be able to open that. Okay. Copy that and I'll add it. So this is the same thing that you also need to do if at all you want to achieve that.
So are we done with the
No, 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 we aren't. We need
okay. Okay,
maybe around 5 minutes. Okay.
okay, okay, no worries, no worries.
Okay. So yeah, so that's done. I have added. I'll bring it back. Okay. So I've added it. I have done it. And all that I need to do is to create a pipeline. So how do you create a pipeline? You have this action tab. You can click on actions and you have to write. You want to create in workflow, right? So there are lots of options you can see from here. Templates you can select, or you can write anything from your scratch. Since the workflow which I've already created, and I would just make use of that. So let's give an name to this CI/CD YAML, CI.YAML, anything is fine. And here you would write all the things that are required in order to do, which I already have, and I would use the same workflow file because that's a workflow file is a very big file. If I type, it would take 10 to 15 minutes. Of course, I'm not going to do that. So I'm just going to take that and I'm going to use that, right? So I'm just going to take that and I'm going to use that. So let's quickly take, and I would just modify it according to our current scenario. So first thing, I'm just giving a name to this workflow called deploy to cloud run, and I'm using the branch main. Okay, so what are the jobs that I want? Right, job steps I want checkout code. Secondly, configure Docker. Third is build and push Docker image, and lastly, deploy to cloud run. Okay, so these are the things that I'm doing. First, let's get started with the first step. So these are fine. US Central one, that's fine. My Docker repo, right? So repository name I should change with. I guess I have given a different name called maybe Spring Boot app. Okay, so let's quickly see what is the name that I've given for the repository. Okay. So we might have given the name called Spring Boot app. Okay. Let's go back. Let's go back. Okay. Or we can just search for artifact repository. Okay. Artifact repository. That's what I told. That's very important to remember the names. So I have given a name called Spring Boot app, or my Spring app, right? So my Spring app. So exactly the same thing I'm going to write in my workflow as well. So the repository name is my Spring app. Okay. This is where I'm going to deploy. I mean, I'm going to push my image. Then service name is should be changed, right? So what is the name of the service? Remember, the name of the service that we have given is, if you come here, if you see, right? So go back, and if you go for the cloud run, let's go. Sorry. Let's go to this Cloud Run quickly. Let's go to the Cloud Run. Okay, so my Spring App Service, got it right? So my Spring App Service, let me quickly copy this name. Let's copy this, and I'm going to use the same name within my workflow, right? So service name is my Spring Boot App Service. Remember, remaining things, image name is your wish, doesn't matter, right? So I'm just keeping it Spring Boot only, that's fine. Okay, you can give any name, that's okay. So let's keep on checking them, right? So these are the credentials and set up the Google CLI and all such things. That these are the basic step. What is happening, okay, is first you are going to, you see the image URL, right? So in the image URL, the name of the image name is given, and all the things are given, right? So I've already given the image name and so on, right? So I have given an image name is Spring Boot, right? So here is the Spring Boot. So similarly, whenever I run the Docker build, I should give the name as same, right? So image URI, you can see that same name I should give. Done. Docker push is happening. Done. And lastly, it is deployment is happening. So gcloud, this is how we deploy gcloud run deploy and name of the service and so on. So everything seems fine. Everything is working, and let's commit the changes and let's commit it, right? Okay, so this is done. And right now, I actually, the moment you do this, you'd be able to see that GitHub action will get started. Okay, and you would be able to see that the steps, you see the deploy, you know, will get started, and you'll be able to see all the steps. If at all you want to see all the steps, you can click on this and you see what is happening, right? Set up a job, check out code, authenticate with GCP. Then quickly what's happening, uh, it is setting up the Google Cloud CLI. Okay, then it will configure the Docker, build and push Docker image, deploy the to Cloud Run, and push and authenticate with the GCP. And lastly, it will whatever like post checkout code it will do. Right. So these are the steps that will go on. Right. We need to wait for some time to see for because it's running for the first time. So first time setting up will take a little bit more time. Now it is done. You see, done, almost done, right? Okay, so it's configured Docker is done, setup, this is done. Build and push. Okay, build and push is going on. Let's quickly see if the build and push also gets successful or not. You see that's going on, and so on, right? So meanwhile, when it goes on, right, so I would see a little bit more questions if you have, and I would try to answer them, right? Okay. It is unclear how two apps with same pod. I explained it, right? Okay. Uh, you got it, right? So I explained it how two apps with same pod works, which parameter makes them. It is not parameter, it's the container itself, right? So all the containers are different. Every application is running within one container, and one container is not connected with other container, right? So they are all separate. Is it done? Let's quickly look at the steps. Yeah, it is done, right? So but now I won't be able to see any difference because we didn't modify anything. So if I go to this, and if I see that application is live or not, if I click on this, you see hello world is coming. Hello world is coming. Now what I'll do, I'll modify my code, and I would see that if immediately all the actions are going on or not, right? So where is the Visual Studio Code? Let me just quickly access IntelliJ IDEA Visual Studio Code, right? Okay, where's the Visual Studio Code? Here. Okay, so here what I'm sorry, I wasn't supposed to show that, but anyway, so you know, in this, let me make some changes. Let's change the message, right? In this, let's, rather than hello world, right? So like Docker is fun, right? So I've just changed the message, and with that changes, I'm just going to push that change, right? So let's quickly, this is the change that I've done. Okay, so you'll just commit and push updated greet message. Done. And let's quickly commit and push. Okay, what's the problem? Okay, no problem. We are supposed to pull it because I made some changes there. So I would just do it using command line as well. It's not a problem. Let's open the terminal. Okay, git pull. Okay, git push. Oh, sorry, git push. Sorry, git pull first I'll do. Git pull, git push. Okay, so I've done a new push, and let's see what is the impact of this new push on my CI/CD pipeline, right? So let's quickly see. Is that getting a new one quickly? You see updated git message. Can you see that updated git message we got? And immediately all these steps will be followed, right? So you see everything is going on, right? And after some time, you will be able to see that new message, all these things, whatever, creating the jar file, deploy, pushing, creating the Docker image, pushing the Docker image, deploy the Docker image, everything would be done in an automated fashion. And all that I would be able to see that I'll refresh, I would be able to see a new message. So that is what we can achieve with the help of a CI/CD pipeline, and how we can leverage, GitHub Action to do the same thing. Okay, so yeah, that is it, right? So you would be able to, you know, uh, let's let it get finished so that you would be able to, yeah, that's an build Docker image is going on, right? And the deployment will go on, right? Once this build is done, then the deployment will also get started, and you would be able to see. So yep, that's how it was, right? So see, Docker is huge, right? So it isn't very small, right? So we have, as you asked me the question on Docker Compose. So Docker Compose is used for running multi-container application. I have, let's suppose I want to, there's an application which has 5-10 containers. If I individually run 5 or 10 containers, it would be very difficult to run that application, right? So that's where you need Docker Compose. And how does a Docker Compose look like? I'll show you some of my repository. Because you know, let's go to my DevOps GCP repository, wherein you would be able to see, right, Docker Compose. If I have to demonstrate, I have all this. So if I say Docker Compose, right, Docker Compose example is also there. So this is how a Docker Compose looks like. Okay, this is how a Docker Compose look like. This is a very pretty simple one. I would show you a complex Docker Compose, right? So this is a more complex Docker Compose. You see, in a Docker Compose file, I have three applications. One is the MySQL. One is, there is one application called Notes user service. One is called Notes service. Okay, and all of them with one single command, all of them will get started, and another single command will, you know, stop all the application. One single command will start everything, will set up network, will set up volume, which we haven't explored, right? What is a volume? Because that's an introductory, this is an introductory session. We cannot learn a lot of things within the span of 1 or 2 hours. Okay, so this is just an introductory session. If at all you want to have a lot of interest to learn Docker or learn cloud, learn GCP, I do, do trainings on, mostly I do only corporate trainings, although, right? So I don't do retail trainings, but if a lot of people are interested, you can reach me out, and I might plan something. Okay, it depends on the number of people who are, if I get a lot of people who are interested, then I might think. But usually I only take corporate trainings. So yeah, I do train on AWS, GCP, Docker, mostly Kubernetes certification, and all such things, right? So these are the domains where I do take trainings, right? So DevOps and all the DevOps tools and so on, right? So if you have any interest, you can connect. I will share you my contact, my, all this information. You can note it down and you can contact me. Let's quickly see that if the application got actually updated or live or not, right? So there was some problem, right? So maybe, okay, so what was that, right? So okay, right, so we'll see that there was some problem, right? In this problem, what was that, right? So image URL, right? So okay, maybe, okay, this is fine, this is fine. Download, everything is fine. At certain point, so much of things are there. Let's Go down. Okay, right. Acha, that's okay. That's okay, right? So if we try it once again, sometimes it fails, right? So that's not a very big deal, right? So it's a uh, you know sometimes it can happen. I can rerun the job and it will work. Okay, so that's not an issue, right? Sometimes because of some unavailability of the zone and all such things that happens, but that's okay. Okay, so we have set it up, right? So the CI/CD pipeline is running and everything is fine, right? So I would suggest, right? So if anybody wants to contact with me for this, right? So all this learning Docker, Kubernetes, CI/CD, any DevOps tools, AWS and GCP typically, right? So I do train on all these, all these things, and but I do corporate trainings. If a lot of people are interested, I can take a retail batch as well, right? So that's what, and these are the places where you can actually reach me out, right? So you can reach me out on LinkedIn, you can reach me out on, you can take a screenshot of this, right? So you can reach me out on Instagram, you can reach me out on GitHub, or you can write a mail to me directly, right? So any of this way, right? So I would suggest you, right? So if you are connecting on LinkedIn, you can write a message, or if you are interested, you can write a message, and we can schedule a session on a detailed session on all these topics, right? So Docker, Kubernetes, and any cloud platform all together, we can prepare, or we can design a course on that, right? So that is what, right? So with that, we would be mostly concluding our today's session, and which was entitled on Docker and GitHub Action. Again, this is, as you know, right, it's a 2 hour session. It just give you some brief idea, or some give you some abstract knowledge on this, right? So of course, in order to learn, in order to know, right, so it needs a lot of time. Okay, so yeah, so that's all. With that, we would be concluding our today's session.
Okay, thank you. We have few question. Can we take those question? Like,
Yeah, can you share me the question, right?
actually, a few questions are on live. I can read those question for you. Is it
Yeah,
fine?
sure, sure.
Okay, okay, okay. How does Docker Desktop manage the underlying virtual machine to run containers on Windows or Mac?
Okay, so what happens if you are considering that, for that you need to understand a Docker architecture. So Docker architecture again is a long concept to make you understand, but for timing it, if I give you a very simple idea. So on Windows, if I say Windows, so Windows, it uses something called WSL, Windows Subsystem for Linux. On top of that, the things run. So whenever you install Docker, it actually install two components on your machine, right? So one is Docker engine, and one is your Docker client. Docker client is the command line that we are using, and Docker engine is or we can say Docker server, so which is where your all the applications, all the containers, all the images and all things are running. So we actually, the moment we write any command, we interact with the Docker server, and this Docker server actually has one process which is known as Docker daemon, which facilitates the communication between the client and the server. And internally, Docker has its, as I told you, right? So Docker has its own file system and everything. So internally, Docker creates a whole system, and whenever you run anything, Docker runs that as a container. And Docker, this every container is an isolated space. And how Docker manages the files, again, Docker manages the files in different layers. That is again a separate long concept. So everything that I'm saying, it itself is a long, or itself is a huge concept to understand. Okay, so in simple, I can say you are just installing a Docker server, or the Docker host, we say, which runs all your application, and we have a Docker daemon which facilitates the communication between, which is a process that runs in the background, which facilitates the communication between your client and the Docker server. Okay, now can we move to the next question?
Yeah, sure. Can we use Docker to the AWS resources provisioning?
Can we use Docker for the AWS
Docker.
provisioning. Okay.
Yes.
So, I'm not exactly understanding your question, but I would give you the some brief idea, right? So yes, the same thing that we have done it uh, with you know GCP is the same thing we can do on AWS as well, and AWS has the dedicated services to run Docker. Okay, and you are saying that Docker to AWS resource provisioning. So it means, like, let's suppose you want to run any kind of resource or anything on Docker. Yes, and nowadays most of the thing, to be very, let me very clarify that. So even if you are running, and let's suppose you are using an Elastic Beanstalk, even if you are using Elastic Beanstalk by default, AWS uses Docker. Okay, so it doesn't create a full-fledged virtual machine for you. It actually creates a Docker container for you behind the scene, right? So it saves the time and it actually creates a Docker container for you rather than actually running a full-fledged virtual machine by default. Although you have the choices, but by default it runs a Docker container for you. Okay, and okay, one question that is, like, I would answer to that question. If you have 10 images and I want first 5 images in one container and other images into second container, then how to run images in one in container? That is that is a wrong question. One image I can run on 10 containers, but 10 image I cannot run on one container. So one container cannot run multiple image. Same image I can run 5 times, which will create 5 container. Absolutely fine. But within one container, I cannot run multiple images. That's invalid. That question is invalid. However, within one container, I can run multiple application. So if my image already has multiple application within it, I can run it. That is fine. But one image one image I can run on one container. Okay, I cannot run multiple images in one container. That's invalid. Okay. uh yeah, any more question that you want to read out? Anything?
Uh, okay, we have so many questions actually. Chetan is asking, for a project slash program management role, what do I need to understand in Docker?
A project slash what was that?
Program management role.
A program management role. Okay, so you have to, first of all, you should see, right, what is it a technical role, or is it an project management has a lot of things, right? So technical is there, you have to deal with the project management, Jira tools and all such things are also there. So it depends on it, what exactly your job role is. You need to understand the complete JD, and then only you'd be able to understand whether Docker is needed or not, right? So Docker is needed whenever there is an requirement for deployment. Means there is an application you need to deploy. So if you are the person who is going to deploy, or if you are a developer who is building that application, both needs Docker. The developer needs Docker to know how to run an application on Docker, how to create the Docker file and all such things. That the operation team needs to know Docker on how, again, it's not on how to build a Docker file, rather how to run the Docker file, how to build the image from the Docker file and all such things. Building the Docker file is developer's responsibility. Running the Docker file, it is operations responsibility. Okay. So that is what. So depending on if you have any role in operations or development, then definitely you would need Docker. Okay. Yeah.
Yeah.
Few more questions I would I can answer if you have.
Okay, okay. Can we host different website with same container pod? We did to host Python, JS, Java
No,
app.
that I've already answered.
Okay,
Because
we are
every
done.
container, if they are running on a different containers, this is also explained with the diagram also. If they are running on a different container, it doesn't really matter, right? So I can run n number of application in different container on the same port, no problem, because all containers are separate and isolated from each other, right? They have own networking. Yeah.
Yeah, we are done with the question, but I have one like a question. Can you please uh, any piece of advice can you share with the freshers especially
Okay.
who wants to learn?
Yeah. So the piece of advice is, like, let me tell you one thing. So since I have been working with some of the top companies around this world, and I have almost, if you look at my profile, you will find all the top companies, like whether it is a top bank like JP Morgan and Chase, or you know a company like Walmart, Flipkart, or it is like in India, if you consider like I have given training for the developers of Reserve Bank of India as well, right? So one thing that I would say in today's world, right? So earlier there was a time like when a developer was like only a person who used to write code. It has been changed. Developer has to do a lot of things, right? Developer isn't only a person who writes the code, right? So over the time, it is the roles and responsibility are keep on increasing. Earlier we had only backend developers, front end developer. Over the time it got combined, full stack developer. We need to know backend, full and front end. Then over the time, what happened, uh, after the full stack, we came to a place where a developer should also know a bit of cloud as well, right? So you should, if you are a developer, you should know, I mean, you might not be an expert, but yes, you should know AWS, GCP, Azure, or whatever it might be. And when you know cloud, you should also know DevOps as well, right? So DevOps, the first thing that comes in the DevOps is a CI/CD pipeline. You should know, and then how to deploy that application. So whenever you are deploying that application, the de facto standard for deploying application nowadays, if I say, right? So if you are building a small application, okay, you can deploy it anywhere, doesn't matter. But if you are building a big application, whether it is the OpenAI's GPT model or any big application in this world, now they are deployed on Kubernetes. Okay, they are deployed on Kubernetes. And what we do on Kubernetes is dealing with the Docker containers. Okay, so Docker is a core part. No matter what kind of developer you are, Java developer, Python developer, Node.js developer, any kind of developer you are, doesn't really matter. You should know Docker. It is a very important thing. No matter whether you are in an operations role, you are in a testing role, you are in a uh, developer role, definitely you should know. And every role, right? So DevOps actually combines of all this together, right? So the operations are there, the devs are there, the test, I mean QAs are there, right? So that is the reason, right? So these are the things with CI/CD, Docker, Kubernetes. These are the things that you should know, right? You should have an idea, or you should know it, right? And it is very important. If you are a fresher, if you want to switch to a different role, or if you want to upgrade, right? So definitely these are the tools that is a mandatory, right? So if you look at any job profile nowadays, if you are seeing there is a requirement for a Java developer or any other developer with 2 years of or 5 years of experience, you would find that it would be mentioned clearly that should know Docker, should know Kubernetes, because this is the de facto standard where we deploy our application. And it doesn't really matter whether it is on AWS, GCP, it doesn't make a lot of difference actually. So once you learn any of the cloud platform or Kubernetes on any of the cloud platform, you can do on other platform as well. That is the best part. So that is one thing. So that is one advice that I would give you, right? If at all you want to progress in this, DevOps is a very good domain. If you are a developer, obviously DevOps, whether it is developer or you are into operations, you are into IT, you are into admin role, DevOps is a very easy to switch role for you, because already you are connected. Now if I say that okay, you want to move to a totally separate domain, that's obviously that's going to be challenges, because that DevOps is much connected. You can easily relate on with whatever currently you are doing. So that's why my personal suggestion would be like, you try DevOps, you try Docker, you try Kubernetes. This would definitely give you a lot of boost in your career. Okay, that's the advice that I want to share. Thank you so much. And please do contact me, right? So please do catch me on this. I do sometimes, I'm not a dedicated person to create YouTube videos and all such things, but I do sometimes make some videos, and you can follow, you can find me on YouTube as well. And yeah, I do some create some content on Instagram as well. And if you want to uh, see, right, some interesting content, right, so on tech only, right, so you can see on my Instagram profile. And obviously I'd be very happy if you are pinging me on LinkedIn. If you're giving me a hi message on LinkedIn, I'd be very happy, right? And you can write a mail to me as well. So that's all about this session. And we would hopefully we'll get connected soon, right? That's all. And thank you
Thank
so much, Preeti, for sharing this opportunity.
Thank you. Thank you so much for delivering such a clear and engaging session. We truly appreciate your time to share your knowledge with us today. And a big full like thanks to everyone who joined us today. We hope you found the session useful and informative. If you'd like to revisit any part or you want to share it with others, the recordings are also available on our LinkedIn page and YouTube channel. So until then, take care, stay curious, and keep learning. See you all next time. And once again, wishing you all a very happy Janmashtami. Thank you once again, sir.
Yep. Thank you.
Thank you. Bye bye, everyone. Bye
Bye.
bye.
Bye, everyone.